Hello.
Morning, sir.
Hello. Good morning. Then, am I audible clearly? Hello. You people can hear me? मुझे सुन Okay,
Hello.
okay. हाँ, hello, बोलो. ज्योति.
Yes, sir. Yes, sir. It's audible, sir. Sir, can you hear us? Hello.
Yes, I can hear you.
Okay, sir. It's audible, sir.
Okay, sir. Audible.
Then, up to this, what we have discussed that I am saying, up to this, we have gone for the concepts like regular expressions and finite automata, and we have gone for their conversions, that is from regular expression to finite automata. And I think you may not have any doubt upon that because that was as possible. I have tried and cleared that one. किसी को फिर भी उसमें से कुछ पूछना है ये अब मैं उसमें रिटर्न नहीं करूंगा इसीलिए पूछ रहा हूँ अगर पूछना है तो अभी पूछ लो. That's why I'm asking. ठीक है आगे जाऊंगा. I will start something new. That's why I'm asking anything from that part. You want to ask, you just ask, then I will move to the new concept that is called GMFA. हेलो.
Yes,
अरे बोलो कुछ तो बोलो.
yes, sir. Start,
Yes,
sir.
sir.
Start creating.
Start new chapter.
Okay, no doubts from that one. I'm moving then to the new chapter. The new concept that we'll go for, actually this is known as the conversion of finite automata into regular expression. Then this is another lemma that we have to prove, and I'm going for that. And how that will be treated, that I will explain. Just a second, I am presenting something. Just go for this lemma. If a language is regular, then it is described by a regular expression. And we'll basically go for this proof based upon the concept of generalized transitions and generalized NFA. Generalized transitions and generalized NFA. Is the screen visible?
Yes, sir.
This is the lemma. We have to go for this is the proof idea. Have you gone for this?
So we have to write there.
Yeah. Then I will go for experiment.
Writing, sir.
Go for this theorem. I'll go for its explanation. I think you have gone for it. Then I'm moving next.
Yes, sir.
Then going for this GNFI concept, basically we'll go for converting a particular finite automata into regular expression. And that's why I had told you that the lemma is, if a language is regular, then we can go for writing a regular expression for it. Got it what I told? That means we can convert a DFA to regular expressions by breaking this into two parts, and we can go for a new type of finite automaton called generalized non-deterministic finite automaton. Then moving for this concept, what I can say that how I can go for this generalized non-deterministic finite automaton. What is it? Then after going for that one only, we can move for the concept of conversion of a particular finite automata into regular expression. And hence, Sandeep, why are you so late? कितने देर में आ रहे हो? Then hence what I have to do, we have to go for the concept just a second. My screen is visible to you.
Yes, sir.
Writing screen.
Uh,
We have to go for it. We can go for that is we can convert DFA to regular expression by breaking बच्चे बार बार लेट में आ रहे हैं by breaking this into two parts using a new type of finite automaton in a new type of finite automaton called non-deterministic finite automaton, or I can say this is GNF. This is the basic concept that we have to concentrate. That means whenever we want to construct DFA to regular expression, on that case in the middle, what is there here I can say that is DFA is converted to GNFA, and that GNFA is converted to regular expression. Understood what I told? DFA is converted into GNFA, and the GNFA is converted into regular expression. Now I'm moving forward. What do you mean by this GNFA? What do you mean by this GNFA? GNFA जो चीज है वो क्या होता है? Getting what I am saying? Are you listening? सुनाई दे रहा है?
Yes, sir.
Then if I want to go for GNFA, तो वो GNFA क्या होता है? What is GNFA? That I have to first know. Then I can go for the remaining.
Yes, sir.
Okay. That is GNFA क्या होता है वो अभी बता रहा हूँ सुनो. GNFA can read blocks of symbols at a time. GNFA has the following characteristics. Then when we can say that a NFA is GNFA? That is the most important point here. What is the time then that we can say this one is a GNFA, not a NFA? How to know that? Getting? कब एक NFA को GNFA बोला जाता है? Here basically there are two properties and I am going for that. Okay? तो एक ऑटोमेटन को कब GNFA बोला जाता है? The point number one. The initial states, or we can say the start state, has no incoming transition. The initial, or I can say what is called start, has no incoming transitions, or I can say this is arrows. और सेकेंड पॉइंट में बोल सकता हूँ the final, or I can say accepting state has no outgoing transitions, or I can say this is arrows. Got the meaning what I told?
Yes, sir.
Got it what I told? That means we can go for this concept of GNFA whenever these conditions must arise. That means I can say that every DFA can be converted into GNFA, and then we will go for showing that the GNFA can be converted into regular expressions. These are the basic things that we have to follow. Then moving for this concept of GNFA, again I can say that the starting state has transitions going outside, but no transitions coming inside. Then what do you mean by that? What do you mean by that? That from any state, no arrows are coming into the starting state. And also, similar case in final state, if I am going to the final state, then I cannot go outside of the final state. Once I will reach, that is the final. I can't come outside of. And if I'll go for some more specific properties of GNFA, more specific properties of GNFA, that is that this is the basic property. To satisfy this property, what are the more things we need? That what are the things that we have to remember? That I am going for. Then going for that, I want to show you some properties like, showing you just a second. I think it is visible to you.
Yes, sir. Visible.
Yeah, basically, I can say that the GNFA is an NFA with the following properties. That is, I told the basic two properties, and those two properties will hold if these are the things that I have separated or specified all the properties. That is, as I told, the starting state has the transition arrows going to every other state, but no arrows coming in from other states. That is, starting स्टेट से दूसरे स्टेट को जा सकता है मगर दूसरे स्टेट से स्टार्टिंग स्टेट को नहीं आ सकता है. I can't come into the starting state. The second point is the number of accepting state is 1. These are the properties you have to remember. You can write or remember, that is up to you. Without these properties, we can't go for converting a automata into regular expression. There are exactly one accepting state, and there is an arrow from every other state to this state. But no arrows to any other state from the accepting. As I told, from the accepting state, no transitions will go out. The third thing is the initial state cannot be the final state. The initial state can't be the final state. Got it? These are the basic concepts of GNF. These are the basic concepts of GNF. Is it finished? Shall I move next? Clear? What do you mean by GNF? That is starting state cannot be final state. There is exactly one final state. There is no arrows going out of final state and no arrows are coming into the initial. With this, I am stopping this and I am showing you how a GNFA look like. I am showing you how a GNFA looks like. Basically, going for the GNFA, how it will look like, that I have to show. Then going for that, I can show you it. Clear your concept in a better way. Then moving for the concept, I can say, let I'm going for a DFA and go showing you how that will be converted into, sorry, I'm going for a NFA and I will show you how it will be converted into GNF. Then going for that concept, let this is a GNF. This is a NFA or not? I'm designing, just see. This is initial state. This is your final state. I'm coming with a from this place to this place with a and from this place to this place with a. Is this a NFA or not? This is your Q1. This is your. This is a NFA.
And
Yes or no? And you know, if I'll go for a DFA also, that is also a NFA. Then how to go for GNF? I am showing you step by step. Here you can see the rules are satisfying. There will be exactly one final state. The rules I am saying, this is rule number 1. As I told you, this is rule number 2. You can go for another rule number 3 also. There will be exactly one set. I'm showing you and accordingly I am just designing. First one, exactly one accepting state is there. Exactly one accepting state
Yes,
is there.
sir.
Yes or no?
Yes.
Yes. And moving next. First rule. No incoming transition to the initial state. True or false?
Not satisfied here.
false.
Not satisfied. Q.
Q1 को incoming connection.
Here you can see that this is the transition which is incoming to the initial state. Yes or no?
Yes, sir.
ये जो ट्रांजिशन है ये वाला ट्रांजिशन इनकमिंग टू द initial state. Then how to remove? For removing this, the steps are: create a new initial state and join with a epsilon transition to the previously existing automaton. This one is the previously existing automaton. Now you tell me, is it now satisfying the rule number 1?
Yes, sir.
Yes, sir.
That is, no, this rule is satisfied. That is, the initial state is the start state to which no incoming transitions are there. समझ पाए? Then, moving to the next step, go for rule number 2. Is it satisfying? Rule number
sir.
2 is
No, sir.
why it is not satisfying? Because
There
you
is a
can see
transition.
that, because you
Q2
can
से
see
Q1
that
जा.
this is a transition which is incoming to the Q2, no problem at all. But here you can see this is the transition which is going out of the final state. But the rule tells you that there should be no transitions going out of the accepting state. There will be no transitions going out of the final state. To make it satisfy, what you have to do? This is the diagram previously existing.
Make another
Here,
final state.
create a new final state and join it with a epsilon to the existing one. Now see the diagram. Is it satisfying the second one? Is it satisfying the second case?
Yes.
Now, is it satisfying all the rules? That is rule number 1.
No, sir. Rule number 3 not satisfied.
That means here rule number T is not satisfying. That means there will be exactly one final state. That means these states should not be the final state because you have added new final state and I have joined this to this. Now is it?
Yes, sir.
Now it is satisfying the rules. Now it is satisfying the rules. That means here you can see no arrows are going out of the final state. No arrows are coming into the initial state and there will be exactly one final state. All the rules are satisfied. All the rules are satisfied.
Yes, sir.
Yes, sir.
Satisfied.
Now that means I can say this is your required GNFA. This is your required GNFA. Understood what is GNFA? What is a GNFA? This is your required
GNF.
GNFA. तो समझ पाए GNFA क्या होता है? It will possess exactly one final state no arrows are coming into the initial state and no arrows are going out of the final state. Is it clear to all of you?
Yes, sir.
Yes, sir.
Anyone, any doubt? Anyone, any doubt? पूछ सकते हो, पूछो, क्योंकि अगर डाउट है तो आगे बताने से कुछ नहीं होगा. Then I'm going for the procedure. That is, what is the basic procedure following which you can convert the automaton into the regular expression. And I am thinking that up to this you don't have any doubt. Okay. And I am thinking that up to this you don't have any doubt.
Yes, sir.
I'm just removing whatever I have designed by thinking that you don't have any doubt up to this. Then, okay, tell me, if I have a n state automaton and I want to convert it into GNFA, what will be the number of states within that?
N+2.
Very good. That will be n plus 2. That means here if I'll go for a 3-state DFA, let I am showing you. And this is what I am showing. I am showing the stages to convert a DFA to a RE. That is, here I am showing you stages to convert FA to RE. That is finite automata to regular expression. The first one, let what I have a 3-state. I have a 3-state finite automaton, and with this I have started my process. Then what I will get from this?
GNFA.
GFX.
I will convert the finite automaton into GNFA. That means it will be equal to a 5-state GNFA. Yes or no?
Yes, sir.
Then what I have to do? I have to go for converting the 5-state DNFA into
Regular expression.
a 4-state GNFA. Then what I have to do? I have to go for converting the 4-state DNFA into a 3-state GNFA. Then I will go for converting this 3-state GNFA into a 2-state. And here I will stop the conversion of GNFA into less number of states. And what will be the 2-state remaining? The 2-state remaining will be the initial state and the final state. It will be the initial state and the final state. And from this 2-state GNFA, I'll go for getting my required regular expression. Okay, this is the way by which I can convert a particular regular expression into a particular finite automata into regular expression.
Okay, sir.
Anyone is having any doubt? Anyone is having any doubt?
Sir, if we start from 4-state FA,
Yeah.
then we have to go up to 2-state,
What
yeah,
will be the
3-state.
number state? What will be the number of state in the GNFA? अगर 4 स्टेट से शुरू करोगे तो
6.
GNFA में कितने स्टेट्स रहेंगे?
6.
6
6
रहेंगे.
again.
समझ पाए क्या बोला?
Yes, sir. Yes, sir.
अगर 4 से शुरू किए तो GNFA में 6 स्टेट्स आएंगे.
सर मैं पूछ रहा हूँ कि ये जो स्टेजेस टू कन्वर्ट में कितना तक जाएगा वो? 2 तक या
मैं
3
समझ
तक?
नहीं मैं समझ नहीं पा रहा हूँ क्या पूछ रहे हो. प्लीज
सर
रिपीट
जैसे
अगेन.
ये सर जैसे ये स्टेजेस टू कन्वर्ट है फाइनाइट ऑटोमेटन टू आरई में, ये 3 से 5 जा रहा है, 4 जा रहा है, उसके बाद 3 जा रहा है, 2 जा रहा है, वैसे उसमें क्या 4, उसके बाद 6, उसके बाद 5, उसके बाद 4, उसके बाद 3, उसके बाद 2 तक जाएगा या 3 तक, 3 में रह
मैं
जाएगा?
क्या बोला हूँ तुम्हें? जस्ट इससे पहले वो पीडीएफ भी दिखाया था, उसमें लिखा था क्या क्या लिखा था? That always our work is to go for the GNFA with 2 states. And what will be those 2 states? The initial and the final. Getting what
Yes,
I'm
sir.
saying? The initial
Yes.
and the final. Except that all the states will be removed.
Okay, sir.
And whenever I reach that position, then only I can, at that position, I can get my required.
Regular expression.
Yeah. At that stage, I can get my regular expression. Is it clear?
Yes, sir.
Any more doubt from anyone else? From anyone else, any more doubt? किसी को कुछ भी पूछना है बिंदास पूछ सकता है, कुछ टेंशन नहीं, क्योंकि this is the last and another information for you. I can say that your internal is going to be held very soon, and the syllabus of internal is up to this. Getting what I'm saying?
Yes, sir. Sir, how the question?
Huh?
Hello, sir. How the question gonna come in this exam?
Not getting what you are saying.
So it will be MCQ type or what type of question?
This is MCQ type. All
Okay,
the
sir.
questions will be of MCQ type. And as you have appeared the previous exams, the questions will be like that. I think in the previous semester exam also you have gone for these type of questions. ये सेमेस्टर एग्जाम भी तो वैसे ही दिए थे ना तुम लोग?
Yes, sir.
जैसे दिए थे वैसा ही क्वेश्चन होगा. Anything more? तुम्हारा आज अभी और कितने क्लासेस हैं?
सर अभी तो सर 2 बजे तक है सर।
कंटिन्यूअस?
ये सर 1 घंटा
Yes,
ब्रेक
sir.
कब है क्या?
सर 1 घंटा ब्रेक है शायद से।
अब कब ब्रेक है? वो ब्रेक का टाइम क्या है?
11 से 12।
11 से
11 से 12।
Okay. Then for the test, I will send you the link and you can appear the exam within 12. ठीक है?
ओके सर।
ओके
12 बजे के अंदर वो एग्जाम जो लिंक भेजूंगा उसको अपीयर करना, क्योंकि 12 बजे के बाद वो लिंक डिसेबल हो जाएगा। ठीक है?
Okay, sir.
I think up to this there is no doubt from your side.
नो सर।
Then we will go for some more examples of this GNFA conversion and design of regular expressions from finite automata, and how to go for that to make it easy. I have already explained few concepts to you, and based upon that you can do it so easily. First of all, I'm taking your attendance, and then I think I'll go for one more example. Then you can leave. Just wait, I am going for your attendance. And within the same time it's opening, I'm just going for some example. Then let there is a automaton like this. There are 3 states. This is your initial state, another state is here, another state is here. There are 3 states are Q1, Q2 and Q3. There are 3 states, Q1, Q2 and Q3. Q1, here it is Q2, this is your Q3. There are 2 states with transitions, and this is designing with overall view. Okay. Here, starting with this, let this is R1. What do you mean by R1 here? What do you mean by R1 here? Any regular expression, R1, R2, R3, and here it is R4. Got it? And this
Yes,
is your final state. And based upon the concept, I want to go for generating the regular expression out of this. I want to go for the regular expression out of this. Then how to go for? तो इसे मैं कैसे लिख सकता हूँ? ऐसे लिख सकता हूँ, देखो easiest way बता रहा हूँ. First I have to convert it into a GNFA. तो GNFA कैसे convert करते हैं? Add a new initial, add a new
final.
final. Then go for the other diagram. Let it is Q1. This is Q2, and this is your Q3. Then connect this with the value epsilon. ये बहुत easy है. This is Q4, and Q1 to Q3 is R1. Q3 to Q3 is R2. Q3 से Q2 है R3, और Q1 से Q2 है R4. इसे join किया epsilon. आई थिंक इट इज क्लियर टू यू कि कैसे बना है, और कुछ डाउट है?
Clear, sir.
Understood? That is, I have converted it into GNFA.
GNF.
Now, मैं इसमें से कोई भी स्टेट रिमूव कर सकता हूँ। देन आई एम, क्योंकि ये कितने स्टेट GNFA है? दिस इज ए
Five.
5 स्टेट GNFA. मुझे इसे किस में कन्वर्ट करना है? 4 स्टेट GNFA में। तो मुझे एक स्टेट रिमूव करना है, तो रिमूविंग, क्या रिमूव करूं यहाँ से? सोचो, Q3 रिमूव करेंगे, स्टेट Q3। ओके, तो Q3 अगर रिमूव हो जाएगा तो इसमें से क्या क्या बचेगा? Q0 बचेगा, Q4 बचेगा जो कि फाइनल है, Q1 बचेगा एंड Q2 बचेगा। हाँ कि नहीं? अरे यही 4 बचेगा कि नहीं?
Yes, sir.
Then I have removed that. What will be the transition now? Previously existing transition is Q1 to Q2 is R4. समझ पाए? तो रिमूव कैसे करते हैं वो बता रहा हूँ, जल्दी से सुनो। Then if we are removing Q3, I have to find out all the paths passing to Q3. तो Q3 को देखे क्या क्या पाथ जा रहा है? एक ही पाथ जा रहा है, वो है Q1 से Q2। हाँ कि नहीं? I have to find it for all paths. तो इसमें से कितने पाथ जा रहे हैं?
एक path.
वो क्या है? Q1 से
Q3.
Q2। अरे
Sorry,
Q3
Q2.
होके
Sir,
पाथ
yes.
बोल रहा हूँ ना। Q1
Yes.
से Q2 एक ही पाथ है, Q3 देके। और कोई पाथ है? नहीं है। तो मुझे क्या करना है? Q1 से Q2 there was a single path existing which will be removed after removing Q3. अगर Q3 को रिमूव कर दूं तो इसमें क्या पाथ रिमूव हो रहा है? एक ही पाथ था। वो पाथ क्या था? यहाँ पे बता रहा हूं। द पाथ इज Q1 से Q3, Q3 से Q2। अगर Q3 बीच में से चला गया तो ये पाथ भी चला जाएगा। हाँ कि नहीं? अरे अगर Q3 चला गया तो ये पाथ
Yes,
भी
sir.
चला जाएगा।
Yes, sir.
देन आई हैव टू मेंटेन द पाथ। तो पाथ कैसे मेंटेन करूं? तो यहाँ पे रेगुलर एक्सप्रेशन क्या होगा? R1, देन व्हाट इज दिस? R2 विथ ए सेल्फ लूप। क्या लिखा जाएगा? भूल गए, कल बोला था। R1 concatenated with R2 with a self loop means R2 star
Star.
concatenated with R3। तो क्या होगा? R1 followed by R2 star followed by R3। ये होगा। समझ पाए?
Yes, sir.
Yes, sir.
देन रिमूविंग द नेक्स्ट। अब ये कितने स्टेट का GNFA हो गया?
4.
ये 4 स्टेट GNFA हो गया। तो मुझे अभी क्या करना है इसमें से?
3 state.
4 स्टेट GNFA हो गया। मेरा काम को लगभग खत्म हो गया। तो इसमें से क्या रिमूव करूं? बोलो, कौन सा स्टेट करूं? Q2 रिमूव कर देता हूं। तो क्या बचेगा? यहाँ पे बचेगा Q0, उसके बाद बचेगा Q1 और उसके बाद बचेगा Q4। हाँ कि नहीं? तो Q2 रिमूव हो जाएगा। तो Q2 अगर रिमूव हो गया तो इसमें से क्या पाथ जा रहा है? देखो, Q0 से Q1 को नो इफेक्ट, एप्सिलॉन रहा। तो अगर Q2 जा रहा है तो क्या क्या पाथ था Q2 से? एक पाथ था Q1 से Q4 थ्रू Q2। हाँ कि नहीं? अरे Q1 से Q4, दैट इज Q1, Q2, Q4, ऐसा ही पाथ था। हाँ कि नहीं?
Yes, sir.
अगर ये Q2 चला गया तो Q1 से Q4 का पाथ चला जा रहा है। तो इसीलिए तो यहाँ पे क्या रहेगा वो दिखा रहा हूं। देखो, Q1 से Q4 क्या पाथ है? एक पाथ है R4। है कि नहीं? दूसरा पाथ क्या है? R1
If
plus, sorry, R2 star R3, तो ये दोनों कौन से ऑपरेशन से कनेक्टेड हुए?
प्लस और
पैरेलल लाइंस, तो क्या होगा? प्लस. Then finally this is converted into last state, that यहाँ पे क्या क्या बचेगा? दो ही स्टेट बचेगा. This is Q4, this is Q0. यहाँ पे हो गया रिमूविंग स्टेट Q2, यहाँ पे लिखा रिमूविंग स्टेट Q1. क्या हुआ? This will be, finally I got R1, R2 star, R3 plus R. And this is your regular expression that is found out of the automaton. तो इस ऑटोमेटन का रेगुलर एक्सप्रेशन क्या निकला?
R1 R2 star R3 plus 4 R4.
समझ पाए सब?
Yes, sir.
Everyone clear?
yes,
Everyone is clear?
Yes.
हाँ ମୁଁ ଜାଣିଛି, ସେଥିପାଇଁ attendance ପକଉଛି. ମିଲ ଯାଅ, ଓକେ, ଥ୍ୟାଙ୍କ ୟୁ. ସମସ୍ତଙ୍କୁ ପ୍ରେଜେଣ୍ଟ ଦେଇଦେବେ ଯେ ଯା. ଯୋଉମାନେ ଏକ୍ସାମ ଦେଲେ ସେଇମାନଙ୍କର ହିଁ ଆଟେଣ୍ଡାନ୍ସ ରହିବ, ଯିଏ ଏକ୍ସାମ ନଦେଲେ ଆଟେଣ୍ଡାନ୍ସ ନାହିଁ ଆଉ, ହେଲା?
sir link କୋଉଠି ଅଛି sir?
ଲିଙ୍କ ତମକୁ ମେଲ କରିଦେବି,
ठीक है sir.
ହେଲା? ତମର ମେଲ ଆଇଡି ଟା ଆଉ ଥରେ ଗ୍ରୁପ ରେ ଛାଡି ଦେଇ ଯାଅ, ଏଠି ଚାଟ ବକ୍ସ ରେ,
ठीक है
ହେଲା? ଥ୍ୟାଙ୍କ ୟୁ, ହାଭ୍ ଏ ନାଇସ୍ ଡେ.